Okay, now we have one question. Heights of men on a basketball team have a bell-shaped distribution with a mean of 185 centimeter and standard deviation of 8 centimeter. Using the empirical rule, what is the approximate percentage of the men between 177 centimeter and 193 centimeter? So when we look at the empirical rule, we see that our data values always fall within the one standard plus minus mu, one standard deviation plus minus mu, and then this will be 68%, and our data values are 95%, which is mu minus plus minus 2 standard deviation, and finally mu plus minus 3 standard deviation fall all of data in 99.7%. So if I want to tell you one more time, if this is our mean value, so our mean value minus 1 times standard deviation, mu plus 1 times standard deviation. So all our data values are here. It's forming 68% of the data. Similarly, when we have, let's say, mu minus 2 sigma or mu plus 2 sigma, where the mu is our mean value, so these data values are 95% of the overall data. So when we look at our question then, so the mean of the man is 185 centimeter. So if I call this 185, and then the standard deviation here for the man is equal to 8 centimeter. So what can I say? So on the number line, if I show that 185 it's here, and my data are bell-shaped data, so this is the peak value, which is our mu. Now we wonder that mu minus 1 standard deviation, where is it? Let's try to start with this. Since mu is 185, and then 1 times standard deviation is 8, it will be 177 centimeter, which is exactly in our question what is being asked. And whenever I have mu plus 1 standard deviation, so it will be 185 plus 8, which will be 193 centimeter, which is exactly in my question. So I can say that by using the empirical rule, the approximate percentage of the men between 177 and 193 centimeter will be 68% of the overall data. Since when we look at here, 1 sigma plus minus mu, I mean mu plus minus 1 sigma, refers here 68% of the data. Now, when we look at the second question, it says that heights of a man on a baseball team have a bell-shaped distribution with a mean of 185. So if I say that X man is equal to 185, and then standard deviation is 8, standard deviation is for the man is 8, and then using the empirical rule, what is the approximate percentage of the men between 161 and 209? So I can solve the question as it was, like a previous question, or even I can say this one. On the left side I have 161. So from my mean value, if I subtract 161, 5 minus 1 is 4, 8 minus 6 is 2, which is 24 centimeter. So now I wonder, 24 centimeter is how many multiple of my standard deviation, which is 8. So 24 is divided by 8, so it will be 3. It means that 3 times standard deviation will be 24. So it's clear that 161 is equal to mu minus 3 times standard deviation. So what about the right hand side? The border on the right, which is 209. So let me check it. 209 and my mean value 185. When I subtract, it will be 4 and it will be 24, and 24 divided by standard deviation, which is 3. So since 24 is equal to 8 times 3, so it will be 3 times standard deviation. So it's easy to see that 209 is equal to mu plus 3 sigma. And so if you remember here, mu minus 3 sigma or mu plus 3 sigma will be this region, which is 99.7%. So we have to say that the number 161 up to 209, it's covered by 99.7% of the overall data. Okay, I hope it is clear. If you have any question, you can make a comment or ask to me later on by using this YouTube channel. All the best. Bye bye.